Good day and welcome. I'm Mr. Simons. Now I'm going to look at the triangle and rectangular problem for my maximum and minimum problems. So in the diagram, again, as I said, always we're going to give you a diagram with unknowns or variables. In the diagram, ABC is an equilateral triangle. So what do I mean with that? All sides are equal. The corner angles are 60 degrees. Which sides have a length of 3 units, so AB, BC, and AC are all 3 units. Then we have DEFG, the rectangle inside the triangle as indicated. D lies on AB, G lies on AC, and F lies on BC. PE equal FC equal X. So there PE and FC are both X. So questions asked, can we first show that this line DE equal x tan 60? Then we have to prove that the area of this rectangle, this area here, can be given by A equals square root 3x 3 minus 2x. And then we have to calculate the maximum area of the rectangle. So without further ado, show that DE equal x 60 degrees. So because it's an equilateral triangle, I need to know that the angle P given there is 60 degrees because it's equilateral. Right, from P, if I say opposite over adjacent, we assume you know that's tan, so DE over X must equal the tan of 60. Opposite over adjacent, tan 60, or Y over X is also tan 60. Right, from there, if I multiply the x away, DE equals then x tan 60 degrees. So we're done answering the first part. So that was just to get the length of that side for the rectangle. Right? Now prove that the area A of the rectangle can be given by A equals square root 3x 3 minus 2x. So first I need to remember that AB is the same length as BC, is the same length as AC, 3 units. So EF there, if this from B to C is 3 units, then EF is 3 minus the 2 x's. So EF equal 3 minus 2x. So for area of a rectangle, I assume you know, there, length times breadth, or DE times EF. D from the previous problem we've done is x tan 60. EF there is 3 minus 2x. So 3 minus 2x times x tan 60. Tan 60 equals square root 3. So that becomes x times square root 3 times 3 minus 2x. So there we have the same equation and we've solved. So hope you follow. So DE we got in the first problem. Right? The breadth. EF we got now, and we're multiplying length times breadth to find the area. Right, now let's look at the next question. Calculate the maximum area that the rectangle can be. So we have the area AX equals square root 3x 3 minus 2x. If I multiply out 3 times that, would give me 3 square root 3x, 3 square root 3 times negative 2x, right? Would give me negative 2 square root 3 x times x becomes x squared. Right, now I need to find the first derivative because they use the word maximum. So a prime x, 1 times 3 gives me 3 square root 3, 1 minus 1, x falls away. 2 times 2 gives me 4 square root 3, and there 2 minus 1 gives me 1x. And the first derivative will always be made equal to 0. So I have 0 equal 3 square root 3 minus 4 square root 3 x. Right? So if I take 3 square root 3 over, it becomes negative 3 square root 3. We always divide by the coefficient of x. So I'm dividing by minus 4 square root 3. Negative divided by negative, positive, square root 3 and square root 3 cancel. So x equal 3 over 4. Right? However, they said we must calculate the maximum area. So my value I got for x must go back in my original equation. Right? So there, wherever I see x, I'm now going to place 3 over 4. So that becomes 3 square root 3 times 3 over 4 minus 2 square root 3 times 3 over 4 squared. Right? We punch that in a calculator, we have 1,95 square units, right? So there we've answered the first one. Let's look at the second problem just to make sure you get enough practice, right? If you're enjoying the lesson so far, and I wish you nothing but the best learning. Alright, Vivian Marais has a piece of land in the shape of a right angle triangle, yep, as shown in the figure below. So there, YAP. She allocates a rectangular piece of land, MOAR, so there's MOAR, giving him the freedom to choose M anywhere along that line, PY. Boundary, let AP equal A and AY equal B, and M equal XY be any point on PY. Term an equation of PY in terms of A and B. Prove that the sun's land will have a maximum area if he chooses M at the midpoint of PY. So there again, keyword maximum. So determine the equation of PY in terms of A and B. Right, so I have Y, 0 and B, and I have P, A, and 0. Find the gradient of PY, Y2 minus Y1 over X2 minus X1. So there, P minus 0, 0 minus A, so my gradient minus P over A. So my equation read Y equal mx plus C, where M now is minus P over AX, and C, it makes contact by the y-axis, by B, therefore C is simply plus B. So I hope you follow and understand. You know how to find gradient, substitute in, and C is always the y-intercept, so my y-intercept is B, therefore just B. So 2.1 done. For the second question, prove that the sun's land will have a maximum area if he chooses M at the midpoint of PY. So first, we should know the area of a rectangle is most length times breadth. At the same time, we have PY, which equal minus B over AX plus B. Right? So for my area of my rectangle, I say X from 0 to M is X, and from R to M is Y. So therefore, X times Y for the area of the rectangle. But there at Y, M is making contact with PY, so I can substitute those values for my Y value. So there it becomes minus B over AX plus B instead of Y. Hope you follow. So point of intersection, therefore I can use the values given by PY. If I multiply out X times minus B over AX, would give me minus B over AX squared. X times B then gives me BX. Right, because they use the word maximum, I'm required to find the first derivative. I don't have A of X, so therefore I'm differentiating A in relation to X. So differentiate A relation to X. 2 times negative B over A would give me negative 2B over A. X, 2 minus 1 would give me X. 1 times B simply becomes B, and X falls away, right? So I differentiate A with respect to X. Again, I'll do it again. 2 times minus B would give me minus 2B over A. 2 minus 1 gives me X to the power 1. 1 times B simply becomes B, and X falls away because it's 1 minus 1. Anything to the power 0 is 1. 1 times B would stay B. Right? Always make it equal to 0 when we're finding maximum. So 0 equal minus 2B over AX plus B. If I take B across, it becomes negative B. Multiply the denominator away, so that becomes minus BA equal minus 2BX. To get X, I'm going to make X the subject formula by dividing away the coefficient, minus 2B. So that gives me minus BA over negative 2B. We simplify, P and B cancels, negative and negative cancels, so I'm left with A over 2 for X. Take X and I substitute it back into the equation of Y. Y equal minus B over A times A over 2 plus B. A and A cancels, Now I have minus b over 2 plus 1b, 1 minus half will give me b over 2. Right? So we should see now, if I found the midpoint of py, it will be simply a plus 0 divided by 2, which gives me a over 2, and b plus 0 divided by 2, which gives me b over 2. Therefore, we can confirm for maximum area, m a over 2, b over 2 is the midpoint of py. So hope you enjoyed the lesson. I hope you follow. Feel free to comment, like, share, and subscribe if you want to. Wish you nothing but the best. God bless. Bye.